Welcome back to Algebra 2, Chapter 5, Section 4 in this book. And what we're going to be talking about are complex numbers, or which are slightly different, but the real topic is imaginary numbers. So, what's an imaginary number? I have a lot of opinions about this. Okay, so if you were doing the square root of 4, and there's a reason why SpongeBob is here. If you were doing the square root of 4, then it could be 2 times 2, that you have a twin to get out of Arkham Asylum for the criminally insane. You kill your twin, you get in the body bag, you zip up, you play dead, and whoop whoop, out you go. And the answer would be positive 2. Okay? Or you can get 4 from negative 2 times negative 2, because 2 negatives make a positive, right? And so then you kill your twin, get in the body bag, zip up, and the answer is negative 2, okay? But what is the answer to the square root of negative 4? I'm going to move it up here so I have more room. Negative 4, okay? So we're here now. What's the answer? Well, the only way to get negative 4 is positive 2 times negative 2, and they are not twins. If I have $2, I'm going to the Dollar Tree, and I'm buying something, probably candy. It may be some Dove beauty cream. I like the little one, the little pink one. If it's negative $2, if I owe you $2, I'm getting nothing. I'm staying home. These are not the same. So in reality, the answer to what is the square root of negative 4 and what it was when I took algebra back in the dark ages of the 80s was no solution. Okay, that's the truth. But along came a professor who said, but what if there was an answer? And we call it imaginary 2. So I always think of SpongeBob when he goes, imagination. And we're going to call it imaginary 2. Now, this is a pure imaginary number, which I always think of that old Willy Wonka, the old one where it's got the decapitated chicken running around, where he sings the song, Pure Imagination. That was really bad. Alright, so this guy came up with this idea to have imaginary numbers. Do they exist? No. And I have always said they were completely stupid and worthless. You can make pretty drawings with them called fractals, and I had no patience with it. Well, my oldest son went to college, and he majored in chemistry, and in pure chemistry, and my major is more biochem. So he has become convinced, in some of the upper level classes he took, that there is a use for it, and what it is that it can be used in proofs. Remember geometry with proofs? There are things that we know are true in math, but we don't know how to prove them unless we go through imaginary numbers. Do imaginary numbers exist? Absolutely not. But I feel like that they're an image of something real out there in math we haven't discovered yet. It's like seeing a picture of something. It's not the real thing, it's a reflection, but there's something real that we haven't discovered yet. So that's another important point. Kids get the idea that everything has been discovered in math and science and we're done. No, there is lots out there we do not know. There's plenty of room for you to go discover the next thing, and you can straighten this out. Now, if I had come out with this, just some low-life math and science teacher from Georgia, they would have just laughed at me and said, you're an idiot. That doesn't exist. But it was somebody important, somebody who went to Yale, somebody who has a doctorate. So anyway, I have a little contempt for this, but you need to know it, and it's easy, okay? So, a complex number has both real and imaginary. The standard form is you write real numbers before imaginary. That makes sense, because at least they exist, okay? There are 4 rules. You're going to treat it like a unit. So here, gathering up the terms, it's just like negative 5x plus 5x. You just treat it like a unit normally. Unless it is I squared. And if you ever end up with I squared, imaginary squared, you change it into a negative 1. So you'll see where we do that in the example problems. Now they made up something really dumb called the absolute value of a imaginary number. And what you do is you square the real part and then you square the number part of the imaginary one. And you know when you square things it takes negatives away and you can get a number. And I'll show you that right over here. How you graph it is you make a different graph where instead of having y, imaginary goes up and down and real goes side to side. So I'll show you how to graph this one. So for real it's 2, you go out 2. Imaginary is -3, you put a dot. Let's do another one. This one, real is -3, 1, 2, 3. Imaginary is 2 and put a dot. So that one goes there. And if this is 4 imaginary, you just go up on 4 and you don't go out on the real at all. So it would be right there. Oh, I did the same color. So that's how you graph them. Pretty easy, get pretty drawings, fractals. Alright, so how do we do one of these problems? Well, here we have, we're going to solve it the normal way. Y is x not alone. We're getting rid of that plus 10 and doing a minus 10 to both sides. Those cancel out. So 3x squared equals -36. Y is x not alone. It's multiplied by 3. We divide by 3. Those cross out. We get x squared equals -12. Y is x not alone? It's being squared. What's the opposite? Square rootified. You think that's a word? No, but it's still fun. Square rootified. I'm going to call it that from now on. And so the square root of -12 doesn't exist. Can't take the square root of a negative number. So we say instead, let's see if I can do it over here. 12 is made out of 4 times 3 and 4 is made out of 2 times 2. So the imaginary goes on the outside, the 2 that gets out goes on the outside, and then you do plus or minus. So it's plus or minus imaginary 2 times the square root of 3, because 3 still has to stay in Arkham Asylum for the criminally insane, otherwise known as under the radical. Alright, so how about this one? Notice this is plus, so this is really just these parentheses are useless. And it's really just a gathering up the terms, woo, problem. So get rid of the parentheses. If this was negative, we'd distribute it, but not, and we're going to gather up our terms. So 4 plus 3 is 7, and negative imaginary plus 2 imaginary is 1 imaginary. That's not hard. So this one, the negative means something because we're going to have to distribute it there. The parentheses mean something. So bring these down, distribute the negative. 1 imaginary 1 times 1 is 1. Imaginary 1 times -5 imaginary. Oh, my imagination's going to break. Is +5 imaginary. Now what do? Gather up our terms. 7 minus 1 is 6. And -5 imaginary plus 5 imaginary, those cancel out. Let's look at this one. So this one I need to distribute this negative. Whoop, whoop. More fun with sound effects. This one's positive, so I can just get rid of the parentheses. Imaginary 1 times this negative times negative makes +2. This negative times positive makes negative. Now what do? Gather up my terms. Reals first. So 6 plus 2 is 8 minus 8. Those actually all go away. Now I gather up my imaginaries. Imaginary 9 plus 4 is -5 imaginary. Alright, let's do this one. We need to distribute the 5. So imaginary 5 times -2 is imaginary 10. Imaginary 5 times imaginary is 5 imaginary squared. But wait, we have a rule. Whenever you get imaginary squared, you change it for a -1. So -1 times +5 is -5. So the answer is, remember reals before imaginary, -5 minus imaginary 10. This one, we multiply. 7 times -1 is -7. 7 times 2 imaginary is 14 imaginary. -4 imaginary times -1 imaginary is 4 imaginary. 2 negatives make a positive. And -4 imaginary times 2 imaginary is -8 imaginary squared. But wait, imaginary squared equals -1. So a negative and a negative is a positive. -7 plus 8 is 1. 14 imaginary plus 4 is 18 imaginary. One more time. 6 times 6 is 36. 6 times negative 3 imaginary is negative 18 imaginary. I wrote them backwards. 3 times 6 is positive 18 imaginary. And 3 imaginary times negative 3 imaginary is negative 9 imaginary. But wait, imaginary squared is negative 1. So this is going to be 2 negatives make a positive, which is plus 36 is 45. And those two cancel each other out. Now go back to what I told you about absolute value. You just squared the numbers. So this is 3 squared plus 4 squared, which is square rooted. So it's positive 25. How in the world? But I won't complain anymore. Same thing with this one. This is 2 imaginary, and see how you have to do both the real and the imaginary? So the real here is actually 0. 0 is our real, if there's not one. So you do 0 squared plus 2 squared is 4, square root of 4 is 2, and I just think that's just a bunch of malarkey. Can I say that on YouTube? Malarkey. All right. Don't let my negative attitude make you feel negative about this. One other thing. I have a program on my calculator called discrimi, and it will give you the imaginary solutions to quadratic equations. You need to get that. If you don't have it, you need to find another one. A quad and B quad, if it's imaginary, says no solution or no real solution. They're old school like me. But you need the new programs that have the imaginary answers on your calculator for when you go to college. Math is great.